Data structures using C. Introduction to data structures. Let me give a very brief introduction to what data structures are. So in this lecture, you will learn about the meaning of data structures. Secondly, classification of data structures and use of different data structures. But we will be dealing in depth as we go and as we do some of these data structures or learn about these data structures. So first of all, let us come to the understanding of what is it. You will hear this word ADT, abstract data type. Now ADT is a mathematical model together with various operations defined on the model. Now this model stores data and allows a lot of operations on the data, either to access the data or to change it. So this is what this ADT does, abstract data type. For example, stack is an abstract data type based on the model of a stack of books or stack of plates, with the proviso that the last item is removed first. You have a stack of plates, you don't remove the lower plate, you remove the upper plate. So that is called LIFO, last in first out, last in first out. So therefore the operations on the stack are inserting an item, that is push, and removing an item, that is pop. So these are the two operations on the stack, and stack has data. This is a data structure in which you have an array and one more variable. So this is how abstract data type defines what kind of data structure we need to have. It doesn't tell us how to do it, but how to do it is done when we write programs for data structures. So data structure therefore is a physical implementation of an ADT. ADT is abstract, theoretical model, and data structure becomes the physical implementation of ADT. Data structure is a unique way of storing and organizing the data in a computer memory so that we can use it effectively. Each operation associated with the ADT is implemented by one or more function subroutine. As I explained in the case of stack, we have got push and pop. These are two functions. Of course, we can add a few more functions to work on the data which is present in a given stack. So data structures are primarily used in almost every field of computer science, like computer graphics, operating systems, artificial intelligence, computer design, and many more applications. So therefore data structures are very, very important, and as computer scientists you should be thorough with data structures. What are the different data structures? Not only theoretical knowledge, you should have a practical knowledge of implementing data structures, this time using C, then maybe C++ or Java or any other computer language. So the question is, what is the need of data structures? First of all, we notice such an amount of data is collected every day, and we are living in an information age. Every minute data is collected, and you have to process this data, the voluminous amount of data. Therefore, it is very important, therefore processing speed is increased, and data structures help us to really process the data in very quickly. Searching data. Every day we go to the internet and we search for data, Google or some other search engine. Searching a data, there is voluminous amount of data spread everywhere, but immediately we get the result. And this is possible because of the various data structures which are used to search for data on the internet. At the same time, there will be multiple requests at the same time for the same data. So how to manage that, etc. So it is done using data structures. So advantages of data structures: efficiency. So data structures are used to increase the efficiency and performance of an application by organizing the data in such a manner that it requires less space with higher processing speed. And secondly, reusability. Once you create a data type, you can use it multiple times for various other applications. Therefore, that is also one of the advantages of data structures. With that, we come now to various types of data structures. As you see here, these are called primitive data structures or data types. They are really, we are familiar with integer, float, character, pointer, etc. in C. And there are non-primitive data structures. We are going to deal with that. Out of those, we have dealt already with arrays and files when you studied the C. Now we come to the special data structures. They are list type. There may be linear list or non-linear list. Under linear list, we have got stacks and queues. Under non-linear list, we have got graphs and trees. So this we are going to deal during this semester. We are going to deal with these linear and non-linear data structures. Here you have got linear data structures and non-linear data structures. So under linear data structure, you have got array, static representation of array. So it is very static. Once it is formed, you cannot change it. But the dynamic would be using linked list to use pointers, etc. We will learn that. And stack also could be a static data type or dynamic data type. Similarly, queue could be a static data type, also dynamic data type, which created using linked list. Under non-linear data type, we have got trees and graphs. So all of them are very important data structures. We will be dealing with them. So here, for example, we take linear data structures. Array is the basic data structure we have been using. As you see, you declare an array, and so many elements could be size of 10. In C, you can 0 to 9, etc. So here you have got a queue. We are familiar with queues, etc. That is the abstract data type. So we are implementing it in C using this. We are implementing it using an array or linked list. So this is called enqueue. You are adding at the rear. You go on adding, as you know, you stand at the queue. Every person comes and stays on at the rear of the queue. Similarly, here also we are patterning that. You are adding, inserting, that's called enqueue. You are deleting from the front. The first person first goes out. Therefore, it is called FIFO, first in, first out. The other one was LIFO, last in, first out. So this is a second data structure queue. We will be dealing with that. And then we come to stack. I explained to you stack. So last in, first out. I go on stacking 1, 2, 3, 4 like that. So therefore, last element will go first, and the first element will be at the bottom of the stack. That will come last. And here you have got a linked list. So this is done. This node is linked with the head node, and like that, this will become the tail. So you're going in. You can go on adding this either at the end or insert it somewhere in between, or also insert it at the before the head also. So that is called the linked list. So those are list structures. Non-linear data type. Here you have got a binary. This is called the binary tree. So this is a root node, and it's called the parent node, child node, subtree, its leaf tree, siblings, etc. So these are called the trees. So level 0, level 1, level 2, level 3. We will be implementing these. It's not only just to understand what a tree is. We will practically implement these data type. And the next one is graphs, very important in networking, etc. So this is how, and the whole books are written on graphs. A lot of mathematics is involved in graphs. So this we can implement, and you can search in and finding the least distance between 2 points, etc. Very, very interesting things are there with these data structures like graph, etc. So we will be dealing with that, all those data structures. I hope you have got a basic idea of what is the ADT, what is the data structure, and what are the different kinds of data structures. In the classes which follow, we will be starting with the stack and then go on learning all these data structures, not only theoretically, but we are going to implement each and every one of these data structures. So be ready for very hard work.